The definition: the least common multiple of the positive integers a and b is the smallest positive integer that is divisible by both a and b. We denote the least common multiple of a and b by LCM of a and b. Here is the symbol of representation of the LCM of a and b, like this. And here is the example, like the LCM of 3 7 equals 21, LCM of 4 6 equals 12, the least common multiple of 5 10 equals 10. Same, using the prime factorization, a equals p1 a1 p2 a2 dot dot pn power an, and b equals p1 b1 p2 b2 and pn power bn, and p1 must be less than p2, less than p3 up to dot 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 less than pn, and ai bi belongs to natural number for I greater than equal to 1 and less than equal to n. So here the LCM of a and b equal to p1 maximum of a1 b1, p2 maximum of a2 b2, and pn maximum of an bn. For example, like we have a equals 60, and this is in the form of the power of the prime factors 2 3 and 5, 2 to the power 2, 3 to the power 1 here, and 5 to the power 1. Same for b equals 54, 2 to the power 1, 3 to the power 3 and 5 to the power 0, and LCM of a and b equals 2 to the power 2, 3 to the power 3, 5 to the power 1, and this is equal to 4 into 27 into 5. So now we can see that 540 is the LCM of 60 and 54. Now here the greatest common divisor and the least common multiple, we are just using some examples. Like you can see that a equals 60 and b equals 54. So first of all, we have transformed the number 60 into the powers of prime, like 2 to the power 2, 3 to the power 1, 5 to the power 1. b equals 54 equals 2 to the power 1, 3 to the power 3, 5 to the power 0. So GCD of a and b equals 2 to the power 1, 3 to the power 1, 5 to the power 0 equals 6. We have already done this while we are studying about the greatest common divisor in forms of the prime factors. And same, the LCM of a and b equals 2 to the power 2, 3 to the power 3, 5 to the power 1 equals 540. So here we found the result in the form of the GCD and LCM of both the numbers 60 and 54. For the modular arithmetic, let a be an integer and m be a positive integer. We denoted here we denote by a mod m the remainder when a is divided by m. Like for example, 9 mod 4 equals 1, 9 mod 3 is equal to 0. Same 9 mod 10 is equal to 9. Same minus 13 mod 4 is equal to 3. So first of all, you have to learn about the modular arithmetic. Here what is given, let a be an integer and m be a positive integer. A is not necessary to be positive integer, it should be integer, whether it should be negative or positive, it doesn't matter. So simply we can use a as an integer and m as a positive integer. So we denote by a mod m the remainder when a is divided by m. So if m divides a gives remainder in the form like 9 mod 4. It means when 9 is divided by 4 gives remainder 1. Same 9 mod 3, it means when 3 divides 9 gives remainder 0. Same 9 mod 10, it means 10 divides 9 and gives remainder 9. Same minus 13 mod 4, it means 4 divides minus 13 and gives remainder 3. And